Hi, welcome back to our lecture. So far in this lecture, we've mostly been focused on networking within AWS and focusing on virtual private cloud infrastructure and related components. And in previous lectures, we covered EC2 computing and things like S3 storage. All of these different components, these computing, storage, and networking components are used to build more advanced services within AWS. And today we're going to talk about one of those service offerings called the Relational Database Service, or RDS. RDS is essentially a managed database service, which allows you to deploy traditional relational databases within AWS. And relational databases are those databases which use tables and tuples, rows and columns, and allow you to form relations between different tables using keys. And relational databases are widely used for transactional purposes, for storing all sorts of different types of data. Now, you could launch an EC2 instance and install your favorite database software on that EC2 instance, and then manage the database software yourself. That's perfectly acceptable, and many companies do that. However, sometimes it can be really challenging to manage a database. It can be, you might need to go out and find people with specialized skills that understand not only how to install the database software, but to cluster it properly, to back up and restore data from the database, the database service, that know how to tune the database engine so that it is performant. These skills are in high demand, and oftentimes it can be difficult to find people with a strong database background. And even if you find somebody with a strong database background, maybe you want them to focus their time and energy on the database architecture and working with developers to optimize queries rather than having to sort of babysit and maintain database software. And that's where the RDS service is really an advantage. You can offload the management and the maintenance of the database service to AWS, and they take care of figuring out how to cluster a database across multiple availability zones, how to back up the database, and so on. And you can focus your time and energy on building your application and integrating with the RDS service. Now, I personally have a pretty strong background in databases, and I have no problem installing database software and managing it. And in fact, I did that for many, many years. Today, however, given the option, I will always choose an RDS service over trying to roll my own, just simply because I don't want to have to spend the time and energy maintaining the database. I just want to use it. And I'll let AWS and their database experts focus on maintaining that database infrastructure for me. Now, when you use the RDS service, you can deploy a number of different types of databases. Databases such as MySQL and MariaDB. Also, commercial databases like Microsoft SQL Server and Oracle. Additional databases include Postgres and Aurora. Now, Aurora is kind of a special database platform. This is a platform that was designed by AWS, and it offers both MySQL and Postgres compatible engines. I'll share with you a little bit later why Aurora is interesting and why it's what sets it apart from your standard MySQL Postgres implementation. When you create an RDS database, what happens is AWS provides you with an endpoint that you can use to access the database. And so when you connect your application to the RDS database, you provide this endpoint, which looks like essentially like a fully qualified domain name, and then you also provide a username and password and a network port to access a database. Now, one of the big concerns when you're working with a database is how do I back up the data in the database? And in the case of an emergency, how do I recover data from my backups? How do I recover that data into my production database? Well, the RDS service supports two different database backup schemes, both automated backups and snapshots. With automated backups, you can define you can specify how many daily backups you want the RDS service to maintain. And what will happen is AWS will automatically perform a full daily backup of your database and all the transaction logs since the backup job started. And it will store this backup in S3. You can then, if whenever necessary, you can perform a full recovery of your data from a stored backup, and then the transaction logs will be replayed on top of that backup. You specify a backup window, typically like in the early morning hours, and then during that backup window, RDS will initiate a backup of your database. And you generally want to do these kind of backups during sort of off-peak hours because the backup process can decrease the performance of your database for a period of time. The other option is to do an RDS snapshot, and you can initiate a snapshot manually or via the API at most any time. And when you do a snapshot, the backed up data in the snapshot is retained on S3, and that's retained indefinitely. So even if you go and delete the database, you could still go to one of your snapshots and recover from that snapshot. And that's actually one way that you can make a complete copy of a database, or you can move a database. You might want to make a complete copy of a database for testing purposes, or maybe you have a staging environment, so you want to make a copy of your production database and deploy it into your staging environment for performance testing or something. So these snapshots are just like you can snapshot an EC2 instance, you can also snapshot your RDS database. When you deploy these RDS databases, just like an EC2 instance, you will select a database instance type, which is very similar to an EC2 instance type. And you will also specify, which region and which availability zone you want to deploy your database your instance into. You have the option of deploying your database instances as single instances or as multi-AZ capable instances. With a single instance, all your data is running on essentially a single server. And if that server or the availability zone that server is running in goes down, then you would lose access to your data. Many of these databases provide multi-AZ capabilities, meaning that you can actually cluster the database across multiple availability zones. And the data between the database servers is synchronized so that if you lose access to one database server, or if the availability zone that server lives in goes down, then your data is going to still be available in another availability zone. And that provides a greater level of reliability and fault tolerance for your application. All of the database types that are offered in the RDS service support multi-AZ. The Aurora database type is a little bit special because it's actually only offered in a multi-AZ architecture. You can't do a single deployment of Aurora, and that's because Aurora consists of at least two database instances that live in three availability zones, meaning that you actually have sort of three instances of Aurora, instances, excuse me, of Aurora running in a clustered configuration, and that provides you with very, very high reliability and improved performance. Some of the database types allow you to create read replicas, and a read replica is basically a separate database instance that's running in a separate availability zone. The data from your primary database is replicated to the read replica. It's synchronized with the read replica. And then your application, when it's performing database reads, it can read from the primary database, but it can also read data from one of the read replicas. And this allows you to potentially scale the performance of your application, because with many types of applications, they actually perform a great deal of reads versus the number of writes. You can, in cases where read replicas are supported, you can create up to 5 different read replicas, and you also have the ability to promote a read replica into a separate database. So you can basically sort of split off, take a read replica instance and split it off from the parent, creating a separate database that is a clone, that starts off at least as a clone of the parent database. Okay, let's jump into a hands-on portion of this lecture, and I'll show you how we can create an RDS database and what the database endpoint looks like. I'll jump over into the AWS dashboard. I am already logged in, and I'm going to access the database, the relational database service. And here I am at the relational database dashboard. I'm going to click on the instances dashboard, and I don't currently have any instances running, but I'd like to launch a new database instance. So I'll click the Launch Database Instance button. And in this case, I'm going to select a MySQL database. And I will click on the Next button. And it asks me, well, what is your use case? How do you plan to use this database? And if I plan to use this database for production, it's kind of steering me towards the Amazon Aurora database, which is a MySQL compatible database platform that provides very, very high performance. And actually, I use this, my organization uses Amazon Aurora extensively. So I do recommend using it for production if you're looking for a Postgres or MySQL production database. Otherwise, you can continue to choose the production MySQL option and use it in a multi-AZ deployment. That's also another very good option. And then finally, if you're just launching the database for dev or testing purposes, then you're just going to launch a single instance of MySQL running on a single server. And for demonstration and educational purposes, that's what we're going to do. We'll launch the dev test instance of MySQL. This is a full-blown MySQL instance, so you could use it for production purposes. However, it's only a single instance. And if you lose this instance, then your application is likely going to fail. I'll click on the next button here. And now I need to select some of these specifications for this database instance that I'm creating. It's asking me for the licensing model. MySQL uses the GPL license. I can select the database engine version. This is like the software version of the database. And you can see there's all kinds of different software versions that are available. This is something where I would want to check with my development team and make sure that we're in sync, because oftentimes they will develop the application with a certain version of database in mind. I'm just going to leave it at the default version. It doesn't matter which version we choose here. And then for the database instance class, this is just like an EC2 instance where we need to select an instance size, and an instance size is going to give us a certain amount of CPU and memory. I'm going to run this on a database T2 micro instance. Again, we want this to be a very inexpensive instance. Some of these database instances can become pretty expensive, especially if you are using the commercial database instances. Something like a Microsoft SQL Server Enterprise Edition running in a clustered configuration on some relatively high-end database instance sizes can cost you thousands of dollars a month. And so this service can be expensive if you're using those sort of commercial images. Okay, we've selected the database T2 micro size. Multi-AZ deployment, we don't want multi-AZ deployment. We're just going to say no. We only want one instance of our database server. We can select the storage type we're going to use. I'm going to use the general purpose SSD storage. We could use provisioned IOPS if this was a production system and we needed high I/O performance. Then the high IOPS or the provisioned IOPS storage selection would make sense. And I will leave the allocated storage at 20 gigabytes. And now under settings, we need to specify a database instance specifier. That's a name that's going to be unique for all the database instances. So this is like the name of our database server. I'm just going to call it my DB server. And then we need to give it a master username. And the master username I'll give it is dbadmin. This is the administrative user for the database. This administrative user will have basically full administrative control over the database service. The dbadmin account does not allow me to shell into the actual database server. This is a managed AWS service, so I don't get shell access to the server itself. The operating system, the software, all of that is managed by AWS. So the dbadmin user just gives me administrative privileges to the actual MySQL database server. And then I need to assign a database password, and I will give it a password. I'm just going to retype this. Okay, I gave it a password, and now I can select some of the more advanced settings. And so for example, I can select which VPC I'm going to deploy the database service into. Just like our EC2 instances, we're deploying an RDS service into a specific VPC. We don't actually manage these instances like we do with EC2 instances, but these are running on virtual machines, just like our EC2 instances are. We can define a subnet group. This is a group which allows us to define subnets and IP ranges that the database can use in our VPC. I'm just going to leave this at the default for now. And then in terms of public accessibility, I can turn public access on or off. If I turn public access on, then that means that EC2 instances and devices that are located outside of the VPC will be able to connect potentially to this database instance if the connection to that database provides the proper access credentials. If I select no, then the database instance will not have a public IP address assigned, and only instances within the VPC will be able to connect to this database instance. And like 99% of the time, I'd recommend selecting no here. Generally, you don't want your database instances to be accessible outside of the VPC in which they're deployed. We generally don't want our database servers accessible from the internet. We only want them to be accessed from other servers within our VPC and application environment. We can select the availability zone that the database instance will be launched into. In this case, I'm just going to say no preference. I'll let AWS choose where they want to launch this instance. We can create a new security group for the VPC or select an existing security group. Or create a new security VPC security group for this database instance or use an existing one. Just like our EC2 instances, we need to associate our database service with a security group. I'm going to say create a new VPC security group. And then in terms of database options, we can define an initial database that we want RDS to create for us inside of our database server. And I'm just going to call this database MyDB. Again, this is an actual database within our database server. And within this database, I can go and create tables and all of the other database components. I define a database port. This is the network port that an application will use to connect with the database. And I can define parameter groups and option groups. These allow us to configure and specify settings for the database engine. And we would generally only kind of change these if we really know what we're doing, if we want to sort of finely tune the database engine for our specific requirements. Okay. We have the ability with certain types of databases to enable storage encryption. This database instance class does not allow us to enable storage encryption, but that is an option for other types of databases and database instance classes. In the backup section, we can define our retention period. this is the automated backup that the RDS service supports. I can specify how many days I want AWS to automatically back up and retain data. For example, I could change this to 14 days, in which case AWS will always maintain a backup of the last 14 days of this database. And I can select a maintenance window. I can tell it when it can start to make a backup and how long that maintenance window can last. I'll just leave it on no preference. And I can set up logging to something called Amazon CloudWatch, which we will talk about in the next lecture. And then in the maintenance, the section, the last configuration section, we can specify whether or not we want AWS to perform minor version upgrades of our database software. And this is something where you might want to be cautious about. If this was a production environment, I might not want AWS to automatically perform version upgrades on the database software, especially if I was just running one database server like this configuration. If I was running in a clustered database configuration, then it wouldn't be such a big deal because AWS would upgrade one server and then it would upgrade the other server in my cluster. If I do allow AWS to perform automatic version upgrades, then I can also select a maintenance window during which it would perform those upgrades. Okay, I think everything looks good, so I'm going to go ahead and click the Launch DB Instance button. And it tells me that your database instance is now being created. I'm going to go ahead and view my database instance. Now, these database instances don't launch as quickly as your typical EC2 instance. In this case, AWS has to launch a computing instance and then perform a software deployment to that instance and configure it. And also, the first time you launch a database instance, AWS will quickly perform a snapshot of that database. And that initial snapshot can take a bit of time. So launching a database can take anywhere from, maybe 10 minutes upwards to 25, 30 minutes, depending on what type of database instance it is and how many instances you're creating. So it can take a little bit of time to start up. I'm going to pause the video here, and just so that you don't have to sit here and wait for the instance to launch, and I'll be back once it's ready. Okay, my MySQL database is now up and running, and it took about 10 minutes for the database instance to become available. I'm currently in the instances dashboard and have my DB server instance selected. If I scroll down here, there's lots and lots of information you can find on the database instance. You can find some performance and utilization information. This section is very important, the connect section, which gives you the database endpoint. And this database endpoint address is what you would use in your application. This is how you would access that database server. So you can see the endpoint address, you can see the port which the database service is listening on. And of course, I configured this database service so that it is not publicly accessible. RDS automatically created some security groups for me. Now, these security groups are probably not the groups I would actually want in any sort of real environment. I would need to configure these security groups to allow access into this database instance on port 3306 from something like my web or application server. If I scroll down even further, you can see details about this instance, the VPC it was launched into, the availability zone it's running in, the instance type, all kinds of information. Just about everything you would possibly need to know about this instance is available on this dashboard. And at the bottom, we can see that one snapshot was performed, and that this snapshot was performed immediately after I initially created the database. And that was one of the reasons why the database takes a little bit of time initially to start up, because it has to perform at least one snapshot. And then if I keep scrolling down, you can see I have access to logs. So for example, if I want to look at this error running log file, I can click on that, and there's just some information that was in this log file because this database service just initially started, and this is sort of bootstrapping information. But you have access to these log files for the database service, which is really helpful for troubleshooting purposes. Okay, so my database is up and running. What can I do with it? If I click on Instance Actions, you can see that I could create a read replica of this database. I could take a snapshot of the database. I could restore the database using a previous snapshot. I could make some modifications to the configuration of the database. I could stop the database instance. I could reboot it, or I could terminate it. In this case, they call it deleting the database server. I'm going to go ahead and just take a quick snapshot of the database. We're pretending that I want to do a backup, a manual backup of this database. I'll go ahead and click on the create a snapshot, and I'm going to give my snapshot a name, and I'm going to call it my DB snapshot. And today is a Friday, so I'll just say Friday. And click on the Take Snapshot button. And you can see that the system is now, AWS is now creating a backup of my database instance. And this will take a little bit of time. If I refresh, there isn't any progress yet. So this will take another maybe couple minutes or so. I just wanted to show you that you could take a snapshot, a manual snapshot of your database at any time to back up the data that's in the database. Well, this concludes the hands-on demo portion of the lecture. There's a few other things that I wanted to cover related to database services. The relational database service isn't the only database service available in AWS. There are actually a couple other database services you can use. One of them is called DynamoDB. DynamoDB is a NoSQL database that uses a document architecture. Remember from an earlier lecture, I talked about 4 different types of NoSQL databases. There was a columnar database, a document database, a key value database, and a graph database. DynamoDB represents a document database, and it's based on the Google Big Table design. Each document in the DynamoDB is basically what we call a JSON object. And we'll discuss JSON objects a little bit further in this course. Essentially, a JSON object is comprised of a set of key value pairs. DynamoDB is a really cool database service where you can take these documents and you can put them into a DynamoDB database. It's a highly scalable database platform. It allows you to support literally thousands and thousands of reads and writes per second with an unlimited amount of data storage backing it up. And what's interesting is that DynamoDB is designed to act like like a very scalable database service. So you're not launching a database instance when you work with DynamoDB. You get an endpoint and you begin pushing data to this endpoint and pulling data from the endpoint, inserting it into the database and retrieving it. And you don't really control the size of DynamoDB. As your needs grow, then DynamoDB grows with you, and it will sort of scale along with the growth of your application. When you put data into DynamoDB, that data is replicated across 3 different data centers. Now, these aren't necessarily across multiple availability zones, but you do get you do get redundancy because your data isn't just in one physical data center, it's in at least 3. Here's an example of a JSON object that you can put into DynamoDB. In this case, it's a user with some personal information like a birth year, and it looks like maybe this is a student because we're assigning some grades, associating some grades with this particular user. This is the sort of data structure that you can put into DynamoDB. Another interesting database option available to us in AWS is Redshift. And Redshift is a managed data warehouse and analytics database. It's what we call an OLAP database. There are sort of 2 general categories of databases out there. We have OLTP databases, which is, most of our standard like relational databases are OLTP databases. OLTP stands for online transaction processing, and these databases focus on maintaining individual transactions. OLAP stands for online analytical processing, and OLAP databases focus on the analysis of aggregate sets of data. So oftentimes these sort of databases are columnar databases where the traditional database table has been pivoted. And what this allows us to do is it allows us to perform and process large aggregate sets of data in a very scalable and performant manner. And again, oftentimes these OLAP databases use columnar storage, and that allows us to provide greatly improved